Okay, GM, everyone, we're live. How's everyone doing? Welcome to Constellation Day 2. My name is Sophia. I'm a developer events manager at Chainlink Labs, and I like to welcome you all to our first session of the day with the amazing Austin Griffith, where he will guide you through building production apps on Ethereum with Scaffold-Eth. So a quick reminder as well, if you haven't done so, don't forget to register for the hackathon at hack.chain.link and in our dev post space. But yeah, to take it away, thank you, Austin, for being here with us today, sharing your valuable knowledge. Definitely, we really appreciate it. And yeah, with that, I will let you take it away.
Awesome. Let's go. Thanks for having me. Thank you for being here. Sign up for that hackathon. Let's go. Let's go build some things. So today I kind of want to do just an introduction to Ethereum development. If you want to get started as an Ethereum developer, the first step you probably want to do is to learn Solidity. The second step is to build a bunch of specific things that'll teach you kind of the ropes. And then the third step is to really just start like shipping your own products and getting those kind of out into the wild. Let me just get started here with Scaffold-Eth. I'm going to do an install here. So I'm going to start from complete scratch at scaffoldeth.io. Here is the link in private chat. Maybe we can send that to YouTube. But what I'm going to do is just grab this link and bring it over here, and we're going to clone. And this is going to be called Chainlink Demo Build, I guess, right? And the very first part, like I said, this first step of getting into Ethereum development is about tinkering and learning Solidity. So what we're going to do, you can use Remix also. This is a similar way to do this, is to go get Remix and start throwing things from Solidity by example into Remix. But what we'll do is we'll throw Solidity by examples in to Scaffold-Eth, and that will give us the ability to have a tinkering app that we can ship to production and go live with it. So first thing I think you do is yarn install. I think it kind of explains it in the docs. If I click in here, it talks about kind of the features of Scaffold-Eth, including hot contract reloading, burner wallets, and a local faucet, and kind of the integrated wallet providers, and a lot of other stuff that you need to have when you're building an app. You don't know it until you start building an app for actual people. And then you're like, oh yeah, we need a network warning when they're on the wrong network and all that kind of stuff. And all of those handy little features are built into Scaffold-Eth. So as you're tinkering around with it, know that you can ship this thing to production if you want. Okay, so let's see. We've yarn installed. Now I'm going to do a yarn. I think it's yarn chain. Let's see. Let's do it in the exact order here. I want to follow these exact instructions. Whoops, that's not going to work. And yarn chain. So if you notice, there's this mpx create eth. There's kind of two ways to install Scaffold-Eth. You can go clone down the repo, or you can do this mpx create eth. This mpx create eth is really handy because you can choose your own adventure. You can pick between Foundry or Hardhat. In this case, I just cloned it down, and we've got Hardhat running, but Foundry is definitely an option, and you'd use this if you like Foundry more. Okay, and let's see, what is our next step? Let's keep following these instructions. We've fired up our Hardhat chain. So we have a chain running, right? Yarn deploy. Okay, so we're going to yarn deploy. And what that does is it deploys an example smart contract. There's an example smart contract that comes with Scaffold-Eth. This is just going to ship that out to our chain. And then there's one last thing we need to do, and that's yarn start. Let's bring up our front end. And this is really nice because now we have a front end that's talking to our smart contract. And this gives us the ability to make small changes in our smart contract and see them immediately in our front end, and then poke at it, hit some buttons and call some functions, right? It's so nice when you can just hit a button and call a function on a smart contract and see what it does. So let's get in and look at our example smart contract to start it off. Remember, you as the builder, you're just getting started. You're trying to figure out how to build cool things on Ethereum. It all starts with just learning the syntax, learning Solidity. And if we get in here and we can look at our contract, there's probably need to make that bigger, don't I? Let's see. Let's make it really big. There we go. There we go. Our contract has a handful of primitive variables. It has a mapping from an address to a uint. So that means that any given address has some counter that we're keeping track of for it. There's events in here, constructor. So this is what runs when you deploy your smart contract. There's a modifier. All of these terms and topics you can learn by basically doing this loop right here. You kind of go to Solidity by example, and you go through each one of these. Let's see, primitives and data types. We're just talking about that, right? All the different types of primitives and data types that you might need within your contract. Let's just grab one of those, right, and paste it in over here and see how it looks, right? So we have some address, right? And if I hit save and I do a yarn deploy over here, it's going to redeploy my contract, and my front end is going to auto adapt to it. And there's going to be some new address there, right? See that address? Let's change that. Let's change that to a different address. Let me paste in my, I don't know. Let's just copy this dude's address and paste it in. We'll see that change right here as soon as we redeploy that contract. Watch right here. Yeah, there we go. There's that new address, right? So this is kind of the interface that you have. You can tinker with your contract. You can paste in Solidity, and then you can kind of interact with it and see how it's working on the front end. Just gives you this nice developer loop where you can kind of really tinker and try things. So again, you're going through Solidity by example. It's soliditybyexample.org. Let me paste that into the chat too, so we have it. It's going to private chat. I think it might get dropped out to you guys or not. I'm not sure, but solidity-by-example.org. Go check it out. And you just kind of like follow through these topics, and you're going to learn. If you're a coder, you're going to learn the language quickly. It's kind of similar to like embedded programming, where you're really worried about memory, and it's a very kind of like it's a very learnable language, though. You'll learn Solidity quickly if you're a good coder. Just go through all of these topics and grab them and mess around with them. So let's really dive into one of them. Let's dive into this mapping right here. So I'd like to kind of clean out this contract and tinker around with it. Maybe let's just take a second to see how Scaffold-Eth interacts, and then we'll go back and we'll learn this mapping. Okay, so kind of starting with this smart contract, we can see we have some kind of like greeter. Yeah, there's like a greeting here that we're keeping track of. That's a string. And then there's some kind of set greeting function that sets that string. There's kind of an interesting thing where if we send some value, it flips some premium Boolean to true, right? So let's just go play with that for a second and see how that works. So there is a set greeting function here, and we can probably say hello world or something like this. And it's going to yell at us because we don't have any gas yet, the upfront cost, right? And so when you're on localhost, it's really nice. You can just grab some funds from the faucet here. I can just click this button and pull down funds from this local chain that's running over here. Woo, come back. And now I should be able to say hello world. Yep. And we're able to update the greeting. There's a whole transaction that happened there, right? Now let's say hello world. Cool, right? And we're going to spend some money this time. That should flip that premium bit. Remember that premium bit we saw there where it's like a Boolean for true or false of whether it's premium or not? I don't know. If you pay, you get the premium treatment. Let's see. Did this? Oh, uh-oh. It didn't. See, next lesson you learn as a coder, you can't send in decimals. So smart contracts don't have floating point math. So what you want to do is have large numbers. So the way we do it is we multiply this decimal times 10 to the 18. And then when we want to show it as a decimal, we divide by 10 to the 18. So you have to remember to hit this little button over here and take it times 10 to the 18. And now when you send it in, it works. And we were able to flip that premium bit. And of course, when you're building an app for your users, you won't have them do this, right? This is an interface for the developer as the developer is building things. And this is kind of a learning moment here. You get in here and you do this for the first time and you say, what? Oh man, what's a big int? I got to go learn all this stuff. This is just the lessons you learn along the way. So let's go back to grabbing that mapping now. We've kind of tinkered around with our contract. We saw how it worked. I kind of want to clear a lot of this stuff out and have a much more simple contract. So I'm just going to like tear this whole thing. Let's see. There's an owner. I kind of like the owner. What don't I want here? Let's see. I just want to clean out maybe we need the owner. I kind of don't want the owner. And by the way, like this is using an ownership pattern that is written within the contract. And the way you really want to do it is probably just import it from OpenZeppelin. And it's right here in the comments. So it's really easy to figure out how to do inheritance and inherit this stuff instead of building your own. I don't even want the ownership pattern. I think I'm just going to get rid of this whole stack. Okay. Come back to a very clean smart contract. And when I deploy, I probably don't have any arguments going in there. Let's try that again. Yarn deploy. This is going to be a very empty contract, right? Oh, no, it didn't even like that. What did I do? Uh-oh. Oh, man, I probably need to, man, I don't know what that is. Probably need to put something in here, right? Let's do an address public. Let's just call it Austin, right? Not even the owner. It's just going to be me, and I'm going to go grab my address here from, here we go. There we go. Okay, and then we put that in there. Now that should deploy, right? This should deploy. All right, cool. So now a very, very simple smart contract out there. It just has this variable called Austin and then some address for me, right? Nothing else, no read functions, no write functions. Hit me up in the chat if you have any questions along the way here. But now it's time to really tinker. We have Scaffold-Eth set up. It's all kind of cleaned out. We want to go learn what a mapping is, right? We've gone through all this other stuff already. What the heck is a mapping and how do we use it, right? Let's tinker with it. So let's get in here and paste this mapping in here. And it looks like there's a mapping from an address to a UN. I'm just saying 256 to be very clear that this is a UN 256. It's using 256 bits. If we did something like a UN 8, you'd be able to have a range from like 0 to 255, right? So we want a much bigger number. And this creates a huge number. So this mapping is saying any given address will have some UN 256 for that address, right? So let's go ahead and then have some function that says like, let's just have our constructor, right? Let's start with the constructor. And yeah, and it's going to set the my map. Instead of setting it for Austin, I want to look at this guy right here, my burner wallet address, right? Notice like when I'm clicking buttons here, I'm not like getting a pop-up from MetaMask or anything like that. With Scaffold-Eth, you start with burner wallets and you use those locally. And then as you deploy it to a more public network, you can switch over to MetaMask and connect or any given wallet you want to connect. But for now, we've got this burner wallet. I'm going to bring that in here and I'm going to set the my map of this burner wallet to 1. I'm going to say 1 ether too. No, let's just go, let's go with way, right? We're just going to go with 100. Okay, so we have a smart contract that will deploy and will keep track of a mapping for any address. Given any address, you get a number out of that, which is perfect for like balances, right? And then we're going to set the balance sort of, let's just name it balance. Why are we calling it my map? Let's name it balance. We're going to set the balance of this dude to 100. Okay, let's see what that does. We're tinkering, we're testing our assumptions, we're trying that out. Let's go deploy it and see what we get over here. Okay, cool. So we have our contract is deployed here, and we can ask it. We can do a read function for the balance, right? So let's copy our address and paste it in here. Notice how this nice field kind of gives you the blocky preview. And if you even have something like ENS, it's going to resolve your ENS and show your little avatar and everything. Really, really smooth, kind of like nice experience, and you can fork these components and use these in your app. Here we go. Let's read our balance. It's 100. It's working. Okay. So we've deployed a token, and the token balance for this dude is 100. So if we wanted to make a token, we would need like one more function here, right? Something that would let us maybe transfer, right? So let's do a transfer function. And what's it going to need? It's going to need, oh, look at that. Yep, fill it in for us. Thank you. There's a to address and some amount. And we're going to require that the balance, I don't even think we need to do this. I think with solidity high enough, it's just going to cause an error if we don't have enough. Maybe we could have that require there to give a better error message, but it's going to cost us money, and the optimizers wouldn't like that. But maybe we'll put it in there just to have a nice clear message that we don't have enough money. then the balance, right? What do? We have some balance mapping. We subtract from the sender's balance the amount, and we add to the person we're sending it to the amount. And that's our transfer function. Let's maybe name it correctly. There we go. Okay, so now we have this cool transfer function. Let's see what happens here. Let's deploy this. Deploying another smart contract to here, right? And now there is this balance function, and we can check it, and we have 100. And then let's transfer. Let's transfer to atg.eth. Let's transfer 50, right? Hit send. There we go. So now when we check our balance, it's 50. And if we check Vitalik's balance, it's 0. And if we check Austin Griffith.eth's balance, it's 50. Okay, so we've kind of have this like token that we've created, right? This is kind of how a token contract works. There's a few other extra functions, but basically you keep track of a mapping, which is kind of just like a lookup table of a number for any given address. And that's all you need for tracking balances. And maybe you initialize some initial balance. And then you have a transfer function that lets you move money. Now let's see, let's try to send money we don't have, right? That's a fun test case. So let's see, we have our current balance is 50. So what happens if we try to send more than we have to Vitalik? It throws a nice not enough balance error. Okay, so let's take that require statement out. This is what I want to test. We're testing our assumptions. We're trying things out. We're seeing how things work. I'm going to go ahead and just pull that require function out and redeploy our contract, and then try to transfer more money than I have and see what it does, right? Actually, this 69 will go because we had 100, right? But now we only have 31. So the second time I hit this send button, let's see what the error is. Yeah, arithmetic overflow, underflow, transfer. What does that mean? It's just a harder error message there, right? You're underflowing. If you only have a certain number of bits and you add one more, the whole thing rolls over to 0, right? Same thing here. We're trying to subtract more than we have. And if we didn't have overflow or underflow protection, our balance all of a sudden would be like infinity. It would be like a really big number, right? So we have that built into Solidity. So we don't technically need even this require statement, but maybe while we're tinkering around, it's nice to have because it tells us clearly that we don't have enough balance, but you probably wouldn't want that in your production contract. Okay, I'm not seeing too many questions yet. Hopefully you guys are getting this ability to tinker, right? You go grab Scaffold-Eth, you follow these instructions to pull it down, you follow the instructions in the repo to get your environment up. You basically have a chain, you have a front end, and then you're deploying. And what you're doing is you're taking your smart contract and you're tinkering with it. You're bringing in concepts from Solidity by example, and you're testing your assumptions and trying out how things work, right? In this case, we built ourselves a little token here. What I want to do now, let's see, maybe we could just actually set this transfer function up. Maybe we could actually, let's maybe build a front end that lets us transfer and lets us show our balance, right? Let's say that we've got our contract built now. It's this gorgeous shit coin called your contract, and we're going to deploy it, right? We're happy with our token. What we want to do is build a front end so our users can use it, right? This is kind of the magic of Scaffold-Eth. After we're done tinkering, we kind of have a front end that comes along with it. Now, we probably wouldn't want our users to have to use this front end. It's a little messy and a little gross. So what we're going to do is I'm going to create a page here on this home page. I'm going to clear this out and we're going to write some React. If you're building consumer apps on Ethereum, I hate to tell you this, but there's a good chance you're going to spend more time in React than you are in Solidity. And that is so sad because the Solidity is so much the cool part and the React is such a pain in the ass. But that's what we're going to build. We're going to build an app that allows anybody to send our little shitcoin around. So here we go. Let's go. Let's get into kind of the two packages that this comes with is Hardhat or Foundry and then Next.js. So if we get into our Next.js and we go to pages, I promised Carlos I would show everybody the Block Explorer. I'm just going to do that now while we're here. Along with kind of this nice faucet that you have where you can send money to anyone, button. That's this button here. And this nice debug contracts page. You also have a block explorer. This block explorer comes with Scaffold-Eth, and it gives you this kind of like local view and letting you know like what's going on here. We can see like we've deployed, this is like since the beginning of this chain that I've spun up here, right? We're probably on like block 50 or something, or block 22, right? We're on block 23 probably. So we're just seeing transactions happening locally, right? Can we even dig into these? I bet we can dig into these and find out, oh, that's so cool. Oh, that's by address, huh? Oh, that's so cool. So shout out to Port and shout out to the Scaffold-Eth 2 team, building an amazing product for quick tinkering, but also shipping your apps to production. Shout out to Carlos. I showed the block explorer. Yeah. Okay, here we go. We are going to build a shitcoin sending app. The product market fit for Ethereum right now. Okay, let's clean up this index.txt. So we're using Daisy and Tailwind here. Oh man, this is, I think I'm zoomed in too far. Let me see if I can widen this and get a better look at this. What I want to do is just kind of clean out a lot of this stuff. So we just get like a hello world here. Does that show up? Let me see. Now I can shrink that over here. Maybe bring that over here. Oh yeah, there's our app. Oh, whoa, where'd it go? Where'd it go? Oh, I dropped it like on my other screen. How do I, I can't even get it. It's like just barely not showing. Oh no. Okay, new screen. Here we go. We've got hello world here. Let me shrink it down just to there, right over here. All right, it's time to write some React. Woo, hope you guys are excited. So we've got hello world here. We're using, like I said, Tailwind, Daisy. We're also using WagMe, and we have a lot of their hooks. Let's show that first. So if you want, you could go to WagMe SH, something like that. WagMe SH. There we go. And you can look at some of these hooks. You can search their documentation. I think what I want to do is use account, right? This is the first hook you usually use. I'm going to do something like this, right? I'm just going to copy paste this in here. So we get the account and whether or not it's connecting. And this thing probably needs to import from WagMe. Very nice. We can clean out some of the stuff we're not using. So our linter is happy. I really don't even want any of that stuff. I just want this address. And let's go ahead and put it in right here. And let's see what our example app does when we hit save. There we go. So now it says hello world and it shows the address that's logged in, right? But that's hella ugly, right? How do we make this look nice? Well, Scaffold-Eth has you covered. It has an address component. So instead of just pasting in the address like this, let's bring in an address and let's set address equal to that. Oh, whoops, that. And it wants us to import it. You want to bring that in from Scaffold-Eth. There we go. And if I hit save, oh, doesn't that look nice? Look at that. Look at that address component. Doesn't that look good? Ooh, that looks nice, right? And if that happens to be maybe someone that has an ENS, let's go ahead and copy my address and just throw it in there. Then you're going to get like this nice, whoa, didn't like that, did it? Oh, I have some extra stuff over there. I'm blaming, there we go. It should give us this ENS preview in a second. That's the thing I wanted to show. Looks like it's not loading very fast, but let's go back to our address here. Okay, what we need to show, right, now it's time to talk to our contract. We've used a WagMe hook to get our address. We've displayed it so we know who we are, right? What we want now is to get our balance from our smart contract, right? So the hook that we're going to use, you can use the WagMe hooks. I think it's use contract. Check out use contract within WagMe. But we have a special hook within Scaffold-Eth that even wraps things even more and gets things even more abstracted and easier for you. So I'm not sure what I'm going to get out of here yet, but what I want to do is get use scaffold contract read. There we go. Thanks to TypeScript. You can kind of autofill a lot of this stuff because it knows the types that it's expecting, right? Contract name is going to be your contract. Don't trust. We can yeah, let's use the types exactly, right? Notice I hit control space there to get function name. And then watch this. I'm going to hit control space and it's going to give me the functions that are in my smart contract. Isn't this really nice? So my smart contract has this variable Austin. I don't know why we put that in there. We can probably pull that out, right? And then it has this other variable balance, right? And so when we come over here and we say, hey, what are my variables? They show up right here as we're editing our front end. And so what we want is to get the balance, right, of, what do we want? Arg's address. That's exactly what we want. Awesome. Watching that chat. Keep chatting. Hit me up if you have any questions. And then what do we get back from this? So we're going to do a contract read on our contract. We're going to ask for the balance and we're going to send in our address. So hopefully it's going to give us our balance back, right? And if we get in here, there's data. That's what's going to come back, and we can rename it to balance, right? Okay, now what does that look like, right? Let's maybe even console log the balance, or maybe let's just throw it in here and see what it looks like. I bet it's going to complain. What's it telling us? Yes. Okay, so it's saying this is a big int or undefined, and it can't be putting a big int in here. So I think what you have to do is maybe like a toString. Let's try that. Let's try toString. Ooh, I think it liked that. Oh, 31. Hey, look at that. Our balance is 31. That's right. Okay, cool. It's working. So here's our address. Here's our balance. What do you think? Maybe like a div with some padding? That's right, because we're building consumer apps. You gotta have things like divs with padding. Gotta make things look nice here, right? Let's see. Yeah, some padding around our balance. Maybe we could make the text bigger, text XL, something like that. Oh, it's so pretty, so pretty. What about like 4XL? I want to see my balance real big. Oh, it's real big. All right, great. So we're able to read from our smart contract using use scaffold contract read. Now, how do we write to our smart contract? Probably use scaffold contract write, right? So that's what we're going to do. We're going to do a write, and we're going to call, what are we going to do? We're going to call this function transfer, and it's going to need some to address and some amount. So we might as well start working on those state variables, right? We'll have a to and an amount. Okay, so what do we need? We need some UI here, don't we? So maybe we have some other div that says like send ETH or something like that, right? Send ETH to, right? And then now we need some kind of address input, right? Now, if you're building an app, a decentralized app, if you're building zoom in. Yeah, I think maybe, do you mean zoom in here like this? Or do you mean zoom in over here like this? Probably there, right? Sorry. It's hard to be able to write code at this Zoom. I think we're good. I think hopefully we can see it. So what I need is an address input. And if you're building an app, you're going to need an address input that has a little blocky preview and does ENS resolution and all this other stuff. And if you start building your own from scratch, it's going to take all day. Just use the address input in Scaffold-Eth, even fork it out of Scaffold-Eth and use it in your project if you're not using Scaffold-Eth. But we have this really nice address input component. All right, let's just go ahead and grab that. I think it will come in from, let's just do this for now and bring that in from, oh man, it's not gonna import it for me? That's lame. I thought that would import. Huh, did it? Oh, it already imported. Okay, it did it like so quickly I didn't even see it happen. Okay. And what do we need here? We need a, let's see, we'll set the value to, ooh, that is ugly. Set the value to address, right? We'll have some state variable called to address. And then on change, we'll like do a set to address, right? Well, let's make it look like this just so it looks a little nicer. Wow, I'm making a mess here. Let's go. All right, set to address to some value, right? I bet it's like this, something like that. All right, now let's see if Copilot recognizes. Yes, thank you. That is great. Maybe we need to bring that in. Awesome. Okay, so now we're tracking some state and we have some address input. What are the other values here? Placeholder, name, key. Let's say, yeah, I like that. That's cool. 0x ... Ooh, very nice. Okay, and then if I put in atg.eth here, I get that full kind of look at the address. I don't know why it's not doing ENS. Let's see, it did it with Vitalik, right? I think maybe mine is a goofy, yeah, that looks very nice Vitalik. Okay, so if we were gonna send some, we're not sending ETH, right? We're sending some token, right? We'll send your token, is that what we're gonna call it? I don't know, it's not our send fake token, right? We'll call it fake token because it's just a mapping. It's nothing more. Okay, so we want to send fake token to this, to some address that we're tracking now in the React state, and now we need an input, an amount, right? So I think there's actually an ether amount or something like this. Ether input. That's what I'm looking for. Oh, that looks nice. Let's see if this does the same thing. Is there some kind of value? And we'll set the value to ether amount or something like that. And then on change, we'll do something like set ether amount. All right, and let's see, this thing should be smart enough to say, oh yeah, you're tracking some new state. Cool, let's do it. Okay, now what do we have over here? Uh-oh, it's broken. What did I do? Oh, I need to close that ether amount, something like that, right? Very nice. Oh, we need some padding, y'all. Got to get the padding in there. I don't know why the AI doesn't just do it for me, man. It should know. It should know I need some padding on my ether input and some padding on my address input. Yep. You guys thought we were going to be writing smart contracts today. Nope. We're just putting padding in HTML like it's freaking 1997. All right, here we go. So we're going to send a fake token to Vitalik.eth. I don't know how many people were actually writing CSS and HTML in 96. Come on. Probably not very many. All right, here we go. Yeah, that's a lot of padding. Okay, maybe we only needed 2. Maybe I'm going overboard with my padding here. Okay, so we want to send fake token and then some amount, right? Maybe we send 10 of them, all right? And then we need some button that does it, right? So we need maybe one more thing of padding here. Let's get a button in that lets us send, right? Button, yes. Class name is BTN dash primary. Oh yeah, send. Give us a send button. Oh, boop. I like it how it bounced in there. That was very nice. All right, and what's going to happen when we click this send button? We're going to call our function, right? It's time to write our use scaffold contract write. So there's some const. I don't remember exactly what I'm going to get back from this. And I want to use scaffold contract write. It's going to be the same thing. There's going to be an object that's going to come in here that's going to be our contract name. And then our function name will be, oh, I saw it flash there for a second. It was transfer. And then our args are the to address and the ether amount, maybe. I don't know. I feel like maybe there might be something a little bit wrong here. My spidey senses are going off, but I'm not sure yet. Let's see. Oh, let's throw an emoji in there. Now, what are we going to have here? A write async. And we're going to call this transfer. So we have this new function called transfer that lets us send ether. And so we can do something like on click. We want to transfer, right? Okay, so now I think we have a few things broken here. It was not happy about this. What doesn't it like about this? Okay, so it's a string and it needs to be a big int. I think what we need to do is a parse ether here. I'm not sure. We're kind of going through this as we go. What do I need to, how do I import? Oh, geez, no, not that. I think I can just bring this in from WagMe, right? And I am failing. No, okay, maybe it's not parse ether either. Maybe it is something else. Does this come in from WagMe? Let's see if it just figures it out, please. from, it's not WAGMI. Is it maybe VM? Let's see. Oh, did that work? Holy cow, I think that just worked. Okay, I don't know if it's actually going to work though. I feel like I want to test this out, right? Well, we're on localhost. It can't cost us too much to try this out. Let's see. We have 31 tokens. I'm thinking that is 31 way. And I'm thinking we want to have this be ether and have it so we have decimals, right? If we wanted to send half, we couldn't do it here because this is in way and not in ether. So let's do this. Let's see. This is a cool thing is you can be writing your front end and kind of manipulating your smart contract and changing things, and kind of your smart contract kind of grows with your knowledge of how it works as you're tinkering with it in the front end too. There's a weird kind of synergy that happens if you're working on both at the same time, and not a lot of folks do. And I think Scaffold-Eth is one of those things that really enables this to happen. But so we're going to have 100 ether instead of 100. And let's just go deploy that and look at that debug tab for a little bit and just kind of go back to tinkering with that real quick to make sure it does what we want it to do. Let's see, where's our deploy? Let's redeploy our contract. So we're in React for a little bit. Now we're back to Solidity. We're back to tinkering around with Solidity and how these big numbers work. Because now if I go to, sorry, I'm gonna have to zoom out a little bit. If I go check my balance, it's going to say 100 ether, right? And if I were to transfer to atg.eth just one, that's going to send one way. So then if we read this, it's 99.999999 because we just sent one right there, right? What you want to do if you want to send one is you have to do 1 times 10 to the 18 and hit send. And now we'll have 98 here. Watch this second. Yeah, there we go, 98. So that's how you transfer one, right? So now our contract is going to change a little bit. If we go back to our home screen, it's going to say, yeah, there it is. Okay, so we don't want that giant thing. We want to wrap that big number right here, I think, in a, instead of toString, we're going to say, format ether, right? And that's going to go the other direction. And hopefully it just imports it. Thank you. There we go. 98.99, right? Very nice. Oh, what did I do? Format ether. Oh, do I need to do like an or 0 or something here? Something like that? Nope. What do I need to do? It doesn't like the big int. Do I just need to say like, do this? Let's do this. Let's say, oh man, come on now. Let's say if balance, we're going to format ether balance, else we're going to have a ... There we go. That fixed it. Little stinking front end problems. They're as bad as reentrancy bugs. Okay, here we go. We've got our balance. It's 98.99. I hate that. That's ugly. Let's redeploy a whole new contract, and then hit reload. What did I do? So if you don't change anything in your deployment, in your contract, and you want to redeploy a fresh one, you have to do -- reset. Ooh. Boom, there we go. Now we have a new contract, a fresh set of 100 tokens. And if we wanted to send some to atg.eth, now if I say 1, what happens when I send 1? Did that send 1? I think that sent 1. Why isn't it R? Oh, 99, it worked. Wow. Okay, that was really slow to reload, okay? Because I think Scaffold-Eth is set to be pulling every 30 seconds. We need to speed that up. Give us every 5 seconds, right? We'll come back to this when we deploy to production, but I think, let's try this again. So let's send 1 to Vitalik, right? Let's send him 42. Send. Yeah. All right. We're able to send tokens around. Okay, let's do this. Let's see. I can log into as myself. I think this is good. I think we're ready to go. I think we're ready to go to production. What do you guys think? Where's chat at? Chat. Swag. That's where chat's at. All right, sweet. So we have a smart contract that we've written after doing some tinkering, learning how a mapping works from Solidity by example. We built ourselves a little shitcoin, and we minted ourselves 100 to start. And we built a transfer function that lets people transfer. Let's take this out. What's the error that we get when we use the UI? It's probably going to be the same exact error, but I just want to see with that line there what goes different. You can just tinker around and try things. This is the best part. So if I try to go send 120, this should throw some kind of error. Yeah, it's just gross. Just a gross error. I don't think I want my end users to get that error. So I would either have to catch that differently or pay the extra money for a better require statement. I don't know if either of those are a good answer. There's probably a third cooler thing that is the right answer. Here we go though. Let's deploy our token. Let's get this thing to a public network, right? It's time to put this out into the world. Let's see. So we need to decide where we're going to deploy this, right? We need to pick a network to put this on. And I don't know exactly where I want to go with this. It is kind of like a token, so I don't know if I want to put it on a real network. I kind of don't know if that's the best. I mean, we could put on like a side chain or something. Let's see. Maybe that's the right way to go. Put it on a side chain. Yeah. Okay. Let's see. I need to get some ETH or let's see. What chain do we want to go to here? I don't even know. We could just do Goerli, right? I feel like Goerli is a good test net, but it's too slow. Goerli's too slow. Definitely sidechain. I think I'm gonna go with Gnosis. It's always my go-to because it's nice and quick. Let's see if I have some. Yep, I got 21 bucks on my burner wallet. Okay, so when we deploy this smart contract, we're not going to deploy it from the usual kind of like zero account, the account that is like the faucet account, this first account on our hard hat node or our foundry node has a ton of ETH in it. And right now when we're deploying, it's just this account that's doing the deploying. That's our local chain. When we want to deploy this thing to a production chain, we're going to have to generate a deployer account. And you'll find this in the Scaffold-Eth docs, but what you need to do is yarn generate. Okay, if you yarn generate, I like that zoom in. Let's go a little bit more. Ooh, nah, it didn't really do much. Yarn generate is going to it's going to create a local mnemonic, and it's going to make sure that it's hidden in your env file, and it's also going to make sure that your env file is automatically get ignored. Okay, and that's awesome because you can't. You would really have to try hard to accidentally commit this private key to GitHub, and it happens, but not very often with Scaffold-Eth because this stuff is all taken care of for you. You notice I'm not like looking at any private key. We've never seen a private key. We're not copying, pasting it around. It's basically happening behind the scenes and it's get ignored. But what it's saying is I've got this new address and I need to send some value to it. I can also do a yarn account, and that's going to display a nice QR code and then go list through my balances. Someone said Sepolia or Arbitrum. Let me see if I have any Arbitrum on here. I don't know if I do. Oh, I do. Look at that. I got 800 Arbitrum ETH on a burner wallet. Man, what am I doing? Here we go. Let's send some Arbitrum to this QR code and see what happens. How much money is that going to cost me? Maybe like 20 bucks? All right, I am sending $20 in Arbitrum to this account, and then I'm going to try to deploy, right? So I'm going to do a yarn deploy, just like we're deploying locally, right? But I'm going to add this extra flag here, and I'm going to say network Arbitrum. I don't know if I've ever deployed a smart contract to Arbitrum. We're about to do it right now, live. Austin shitcoin on Arbitrum. Let's go. Please work first try. We got transaction hash. We got deployed. I think it just went, right? Okay, so we put our smart contract out on Arbitrum randomly because someone in the chat said Arbitrum. And then what we need to do is put our app on Arbitrum. If you still look at this, it's still looking at my fake token on Hardhat. So this is another really cool thing about Scaffold-Eth that it handles for you is this network here. As soon as I put in Arbitrum here and hit save, everything is going to, oh, whoops, I need burner wallets too. I'm going to go ahead and keep burner wallets awesome. So now my entire app is on Arbitrum. By making that one change there to Chains Arbitrum. Now, anytime you click on any address in your app, it's going to take you to Arbiscan, the Arbitrum Etherscan. Isn't that really nice? So whether we deploy this to Arbitrum or Optimism or any given L2 side chain, any EVM compatible network, you're going to have all these really nice features like this nice looking address. And when I click it, it's going to take me to whatever that block explorer is for whatever that network is. So it's super easy to YOLO this thing to any given network, right? Okay, so we are live on Arbitrum with our fake token. I don't have any ETH though. This guy needs, we need a little gas. Let's gas him up. Let's go. So I'm going to use, again, my Punk wallet. I'm going to shoot that dude. He probably only needs like $1, right? We just need gas money. So hopefully, oh, look at that. It's so fast. Gosh, dang. All right, now we should have 100 tokens. I want to send 69 of them to atg.eth. Are you ready? Here we go. Sending our shitcoin on a live network from our app. Does this work? I have no idea if this is going to work. Wow, I think it might work. It's thinking. It's thinking. It looks like it went. Waiting for our app to show. Yes, it worked. We sent our coin. And there we go. We can see it live. That cost me 16 cents. That is really cool. Okay, so now it's your turn, right? I want you to be able to send around this stupid coin that I made just now. So the way that you'll do that is you'll need a URL. You'll need a front end, right? You could technically go out to this contract and you could, is it verified? It's not. Can I verify it? -- network Arbitrum. It's not going to work because it's going to tell me I need an Etherscan API key for Arbitrum. Yep. Okay, so because I don't have an API key for Arbitrum, I can't automatically verify this. But if you have one, you add that into your ENV, and then you do this yarn verify, and your contract's verified, which is a very nice thing to have. I'm sorry that this coin is not going to be verified. Dang it, that's too bad. Okay, let's deploy our app though. We've got our smart contract out there. You could technically interact with the smart contract directly if you wanted to, but what we need is an app for people to use, right? This is a consumer app, right? So what you would do is you would do a yarn build or a yarn, let's see, yarn Vercel. It's yarn Vercel. It's moved from this. I think if we go look at let's go look at the docs, right? How do we deploy our front end? Oh, let's go to the documentation. Oh, okay. There's got to be something like shipping your app. Yes, deploying your Next.js app. Oh, okay. We just do a yarn Vercel. Yarn Vercel -- prod. It tells us how to configure stuff. Okay, let's do this yarn Vercel. Sorry, I had to go to the docs. Just wanted to show that they're there. What happens if we do a yarn Vercel? I think it's going to say something like, let's see, set up and deploy. Yes, I want to set that up. I'll put it on my own. No, it's not named this. No, it's not. What are we calling this? This is just a Chainlink demo app. It's not even a Chainlink though. I'm just gonna say demo app because there's nothing Chainlink on here. It's just a dumb token. Okay, let's see if this works. There we go. Looks like it's uploading to Vercel. Now I think there's probably some linting we need to do. We need to do a check types. Like before you deploy this thing to production, let's just run that real quick while we're here. You do something like yarn next check types, and it's going to check all your types and make sure that all your type safety checks look good. And we're also going to lint that thing, right? Let's clean it up and make it look good. Make sure I don't have variables that are unused or anything like that. And if I do, look at that, super clean. You guys knew I was a clean coder. You guys know it. If anybody has looked at my GitHub, you know that is not true. But we're good. This thing is going to Vercel. Like basically, we've deployed an app. We've put the smart contract out on Arbitrum. We've moved our front end to point to Arbitrum. We can still debug if we want to. We also built a nice little front end that lets us send. Oh, I can verify an Arbiscan by connecting my wallet and pasting in the code. I could do that too, right? They're probably like a flattened version of that contract and paste it in. I don't want to do it manually though, like some kind of a peasant. I would just put in the API key and do a yarn verify. Okay, so I guess what we're really waiting for this to do is build, right? Most of this is like front end stuff, but if you make stuff that people will use, you're going to have to write a lot of React and have a lot of front end stuff that you're waiting on. But hopefully this helps you get started. Now, if we zoom way out, I was talking about there's 3 major steps. The first major step is this, tinkering. You grab Scaffold-Eth or you grab Remix, you go to Solidity by example, and you go through all of this stuff. I mean, you go through every single thing, learn every single thing on here. There's so much really good stuff here. In particular, learn all the basics. Make sure that you know how to make an array of structs. Check out this to-do list where it has this struct to-do, and then it has this create function in it. It takes this array of to-dos and makes new to-dos. It makes a to-do list, right? You probably don't want to put a to-do list on mainnet Ethereum, but this is going to teach you how to make an array of structs. And that will be very handy for tons of things. Like if you're making a DAO proposal system, you'll want to have a proposal in a struct and kind of be able to iterate through those. But if you don't need to iterate through things, you can use a mapping, right? That kind of mapping that we use today where it's like for any given this primitive, you get a bunch of these primitives, right? So for any given address, there's a uint. And we kind of played around with that today and how we can make a token with it. Okay, so that's step 1. Step 1 is tinkering with Solidity. Step 2, you need to build a handful of things that are going to specifically teach you a bunch of lessons about how and what you deploy on Ethereum. And to do that, go to speedrunethereum.com. That's the next link I'm going to throw into the chat here. I haven't had links for a while, but once you're good at Solidity, once you've tinkered around enough and you can make an array of structs and you can make your own token with some mappings, you are ready to speedrun Ethereum. You need to make a simple NFT first. By the way, this is using Scaffold-Eth too. So you have modern tech behind this modern curriculum that teaches you the aha moments about what you can and can't build and why you're building things. Specifically, look at this decentralized staking app. It really teaches you that the superpower of Ethereum is allowing you, the builder, to create a simple set of rules that an adversarial group of players can work together, right? They can basically use your app as a coordination tool. Even though they don't trust anyone else in the circle, a whole circle of people can get together and they can coordinate financially or otherwise, right? And so these apps are specifically built for these like trustless environments where like trust doesn't scale. You need to be able to build something that anyone has access to, but then you can't trust them, right? You have to write the rules correctly and you have to trust that smart contract will do exactly what the smart contract is programmed to do. And that's the thing that you have to trust. Token vendor, right? How to make a token, how to sell that token out of another contract. This teaches you contract to contract interaction. This teaches you the ugly approve pattern of ERC20s and how you have to make 2 transactions. You have to approve on the token contract and then go to the other contract and have it go get the token out of the token contract. It's crazy. And then we have a dice game. It teaches about randomness. Randomness is really tricky on chain. On a public deterministic blockchain, randomness is really tricky. Go play this dice game. This dice game is going to set you up so you basically pay money to roll the dice. But what you can do is create a smart contract that looks at what the dice are going to roll and only pay for rolls that you'll win, which is really fun, a really fun little dice challenge. Then you're going to build a DEX. You learn how a hyperstructure works, where you can deploy a smart contract. It's going to live forever. Not even you can stop it. It's going to do exactly what it's set to do. And if you set it to do something like calculate a price between 2 assets that are held in reserve and let you swap between the 2, but not just that, you're going to need LP providers. So a third party comes in and provides liquidity, and that makes the swaps work. And so what you do is you charge a little fee, and that fee goes to the liquidity providers. Really, really neat concept how a DEX works. Then on to state channels and scaling and signatures and a multi-sig wallet and so many other cool things. Check out Speedrun Ethereum. That's the second step. The third step, you just have to build in public. Keep shipping things. Start building things that are interesting to you. Go down, I think we have at the bottom of buildguild.com, we have a tech tree. Go through this tech tree and just smash everything on it. Get good at building all of these things. And then of course, eject out to, either deep EVM learning, the Ethernaut, other code arena type places, CodeHawk, shout out to Patrick, who will be on in a little bit. Go down the ZK route, the ZK gaming route, so many cool things to do. So get good at the syntax. ship a bunch of apps from Speedrun Ethereum so you learn the basic concepts, and then go start building your own things. Those are the three kind of major steps that are going to lead you to being a good Ethereum builder. Okay, I think our app is ready to go. Are you guys ready to trade around my stupid fake token? I know I am. So I am going to disconnect now, right? We have this demo live app. Okay, I'm going to paste it in. I don't even know. Maybe you could send me your address and I could send you some of this token. I feel like not sending this token is probably the most legal thing I should be doing right now. So I'll probably just burn this token. Maybe I'll send it to zeros and then the entire, yeah, let's do that. Let's make sure that this token can't be sent by burning it all. Okay, you'll see that Austin Griffith now has 69 fake tokens, right? And I can send them to anyone, right? If Vitalik.eth was out there and he wanted one, I could hit send, and this would, oh, wrong network. Wait a minute. It's telling me I need to switch to Arbitrum 1. Oh, sure. Thanks, app. I'm sure glad I didn't accidentally send a mainnet Ethereum transaction. Isn't that handy that that nice little network switcher is there? I will be using that. That's great. Okay, so now if I were to hit send here, it would send one of these fake tokens to Vitalik. Let's see, there's my MetaMask pop-up. I'm going to go ahead and reject that because I think I want to send these to zeros. I want to get rid of it, right? I want to burn it all, right? Let's burn these. Okay, what's the zero address? Can I just Google zero address Ethereum? Yeah, that's what I want. That dog right there. Oh man, I've got an extra parenthesis. Get rid of that X. Oh yeah, that's the dude, the red and blue dude. I recognize it. Send all 69 to the zero account. Here we go. We're gonna burn them on Arbitrum. Here we go. Boom. Okay. And so actually, I think our burner wallet still has some, but we were able to make a smart contract. We were able to deploy that smart contract. We were able to tinker with it using this debug contracts page and figure out how a mapping works and make a transfer function that lets us send stuff around. Then we were able to kind of build out a front end. We used these nice Scaffold-Eth components. We used VM and WAGMI and all the latest tech in the space for building consumer apps on Ethereum. And then we made ourselves a little token for some reason that has a balance of 100 Ether for our burner wallet, and we can transfer things around, and we have the front end to do that. And then we deployed the app live to Vercel, and it still hasn't been an hour. We can still do some more stuff. So you guys should definitely check out Scaffold-Eth. Get to building, get to tinkering. I think we can kind of like end it at the top of the hour, but I'm like available for chats, available for questions. Let me see if there's anything else in here. I was thinking maybe I could do like a cool Chainlink build. I found this cool speed run. I went to Build Guild, the app, and I searched for Chainlink, and I found this cool speed run Chainlink demo app that takes you through price feeds and VRF and automation in Scaffold-Eth too. And I was going to set up a VRF so we could roll some dice, but all we got as far as we got was making a shit coin. And I apologize for that, but that's my skill level. Okay, we went live to Arbitrum. Any questions? Anybody out there have any questions? I'm just looking right at the YouTube chat. So if you want to just YOLO something into the YouTube chat, I will try to answer you. Thank you all. How much coffee did this take? I definitely whaled a large coffee. It was delicious. Yes, local brewer here in Fort Collins. Delicious. Let's see what else we have. Any questions? I don't see any more questions. Now, the next thing is like go hang out with Patrick, right? Like this is like level 1 here. Level 2 is hanging out with a homie Patrick. He's going to take you through probably gas optimizations and audits and much higher level stuff. Like this would be after you have a complicated smart contract and you want to make sure it's very safe. And he's going to tell you things like, don't have this require statement here and don't pay for this. There's probably a better way to catch some kind of custom error and then display a perfect thing in the front end. But yeah, shout outs for Patrick. Woo. See you guys in a little bit. Thank you, Chainlink. Thank you for having me. If there's any questions, hit me up. Boop, 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 boop. Don't forget to run Ethereum. Thank you, Sophia. Whoa.
Just so there's actually have problem with verifying work.
Oh, I always have a problem with verifying. The Scaffold-Eth make that command actually work. Yes, if we were to deploy to... Oh, I think I'm catching some feedback there. But if I were to deploy this to, I don't know, let's try deploying to like Orly or something. If I were to deploy somewhere that's not arbitrage. Oh man, I think, is that Sophia? I think your audio is fading back. I'm not sure. But yes, you can use this verification. There's a -- verify, that yarn verify that I did there. This usually works. What you need is API keys for different block explorers. We don't have all of those built in, but if this was on mainnet, you would do something like network -- network mainnet, and it would verify the contract on mainnet Etherscan. So yeah, sometimes it is a pain to get those contracts verified, but all you need here is an API key for that specific block explorer, and it should just verify it automatically for you. Thank you all. So many thanks in the chat. Love to see that. Love to see that. Hearts, hearts, hearts. Thank you very much. Oh, let's see. Is my screen still sharing? Let me show you. This is me on Twitter. I'm at Austin Griffith. This guy right here. DMs are open. Here, I'll just even paste that in over here, and maybe it will make it all the way to YouTube chat. But hit me up. That's me on Twitter. Ask questions. DMs are open. Go the manual, do the manual peasant work. I don't want to, man. He's saying you should just go grab. Oh, duh. I deployed this with Hard Hat Console. I should not have done that. So before you go to a live network, you definitely want to comment this out. The reason, there's a whole bunch of stuff here that now, if I wanted to manually verify this, I would need this whole library too. If I could just comment this out and redeploy it, and all I had to do was just paste this into Etherscan, I could manually verify it. But the fact that we brought this console log stuff onto mainnet Arbitrum means that it would take a lot of work to paste all the code in. So I can't even do the manual way. Oh, something happened with that link in Twitter. There's like a weird space there. Yeah, someone else got it. Thank you. Thank you, Roman. Hearts, hearts, hearts. Thank you all. Check out Scaffold-Eth. Check out Solidity by Example. Get ready for Patrick to melt your face in a little bit with some awesome auditing tips. Go check out all the new cool products that Chainlink is putting out and build something cool for the hackathon. Just ship things over and over again. It's okay. You're not going to have a grand slam with your first build. Just build things for curiosity and to try to learn things and to test your assumptions. Okay, hearts, hearts, hearts. I think we're about done. What do you think? How are we doing? Anything else? Any last questions?
Yeah, we were on time. So thank you so much, Austin. As he mentioned, we'll be back in 30 minutes with Patrick. So be sure to stay tuned, and I will see you in 30 minutes. Thanks, Austin, again.
Ooh,
and we'll
good question there. How do I test local hard hat if I'm doing Chainlink? Yeah, with Chainlink functions, I feel like with Chainlink functions, you're going to need to be on a test network, but maybe that's not true. I haven't like dug in far enough. Yeah, see, like when I hover this, just go do it on Polygon. It's so cheap. Just test, literally test in production. Like go test your functions on Polygon and it'll cost you like a penny or something, right? I don't think you can test on localhost, but maybe someone who's smarter with Chainlink knows how to do this. But as far as I know, I think it's you need to be on a test net because you need that infrastructure and you need that public network. But I bet there's even like a test network, right? When I hover over these, yeah, they're not showing test networks. I'll bet you $100 there's a test network for this. Let's see. How do I? Sorry, we're just like reading the docs live here. I'm not seeing a test network yet, but I would almost guarantee that like you can deploy this to Sepolia or something like that, but it's just going to be some public network. It probably won't be a local blockchain. I think you'll need to be on a public network like Sepolia or Goerli. That's my guess. Sorry, I don't have a better answer. Hey, look, Constellation is going on. Are you guys checking this out? Let's sign up now. Go do it, Anon. Let's go. Register now. Awesome. Okay. Hit me up on Twitter. Hit me up. I don't see any other. Yeah, Mumbai, someone says. Nice. Ooh, go sign up and win. Yeah. Awesome. Okay. Are we out? Are we good?
We're out. Thank you, Austin.
See you guys. Hearts. Thank you.